Hello and welcome back to Java Programming. In this video, I'm going to introduce our next module and then dive into the first step in the next module, which is high-level design. So this unit, Unit 3, is all about building a real application. And we've been building real applications up until now, but we haven't really built one from scratch. We've provided you with kind of recipes of what to create, but many of you have had questions about, well, okay, what about when somebody doesn't tell me what the classes are that I should build? And you guys did a little bit of design with the TV, radio, home entertainment assignments. You got a little taste of that, and we're going to continue with that in this unit. One thing that I should say is that there is no single right answer on developing or how to design any application. I think if you put, 10 designers in a room and gave them a big system problem, there would probably be 10 designs that came out of that. So we're going to show you one approach. I think with applications that are smaller, like the ones we'll be working with, you'll certainly all have very similar designs, and I'm going to kind of guide you towards a design that works for the application that we're headed towards, both in the example and in your projects. But I think that's easier for learning purposes rather than throwing something really giant at you. So I kind of have in mind how maybe a best way, at least at this size, but just be aware there's lots of different ways that we could go with development, and we can talk about those things, like why is one set of classes maybe better than another, and some will have advantages over others, and you might choose one option over another based on things like performance or maintenance down the road and that type of thing. So we'll talk more about that. So there are several different steps that we kind of go through as we're building an application. We want to think about what the goals of the application are. So you can imagine somebody coming to you and saying, hey, I have this problem. Can you build me an application to solve that problem? And we'll take a look at the application goals for this example application in a little bit. From there, then we can think about high-level design. So at a very, very high level, what should the application do? And that design should be sure that it meets the goals. Okay, so solves the problem that somebody came to you with. From there, then, we start thinking about within that design, maybe a flow of what the application will do, and we might start thinking about what different classes we might need in order to solve that problem. And then from there, we'll get a little bit more specific and write something that we call prep code or pseudocode. And none of this is Java specific, so you can go through this process regardless of what language the application is going to be written in. Prep code is an English-like language that helps us decide and define what a method or function is going to do, what instance variables there are, and kind of think through and write down the logic. Sometimes it's difficult to write code at the same time that you're trying to figure out kind of the algorithm that you're going to be using. So prep code allows us to tease those two things apart. It allows us to think about what things need to be done. And then later when we write our real code, then we can think about, okay, what's the Java syntax for that if-else statement or that kind of looping or whatever. So prep code is a lot of fun to write because it's just in English, and we can really get into the nitty-gritty of what are the different pieces that need to happen. And then later we sort of use that as our recipe or our blueprint for writing the code. Test code. So obviously any code that we write, we want to make sure that it performs correctly, it does the right thing. So if we're writing a calculator application, we want to make sure that when we enter 2 plus 2, that we get back 4. And so test code is the way that we can do that. And so we write code that will actually test our application. So we're kind of writing a program to test our programs. And so that's, for me, a lot of fun. I like that automated testing aspect of things. If you write really good tests at any point in time, you can kind of push a button and verify, yep, my application is still working as expected. And I don't have to physically enter information at the command line to make sure that that application's working. I can really just run this test program, which then exercises my real code. We'll look more at that as we proceed. A couple other things. We will be gathering input from the user at the command line. So we'll have a little bit more interactivity in the projects that we're working on in this unit, the labs and the projects. So that's, I think, a little bit more realistic. There are certainly batch applications where they're reading files and that type of thing, but I think having some interaction makes it more fun to build. Next up, random. So some of you are familiar or have looked into some of the different math options, and there's a math class that can provide us with random numbers. So we'll take a little peek at that, and the math class does tons and tons and tons of stuff that we'll look at throughout the semester. Being able to just generate a random number for us is one that we'll use in this unit. And then we'll keep practicing with looping and using not only sort of that traditional for loop where we've got a counter that we increment, but we will also look at enhanced for loop, which is a little bit more modern way of looping. And some of you may be familiar with for each loops from other languages. So we'll take a look at Java's version of that in this unit too. So without further ado, let us jump into an application. And for the next several demos and lectures, I'm going to build out or show the design of an application right from the beginning. That application code is available here, and I'm not going to show that code until we've actually sort of built it through this process. But if you're interested in where we're heading, you can take a look at that ahead of time. Is defining the goals of the application. Then we do some high-level design. We figure out what classes we're going to need. We write that English-like language to figure out what's going to be happening, and then we worry about writing some real Java code here in the last two steps. So let's start off with this application. Suppose that somebody comes to us and they tell us that they need an application for their kennel to figure out how much food they need for all of their dogs for a week. So they need a way to input dog information into the system, and then the system should figure out, okay, you need 50 pounds of food based on how many dogs you're supposed to have for the week. So that's the goal. So that kind of checks off this very first piece. We've got a customer, they want a system that does something, and they've told us what that something is. So our next step then, to kind of help communicate with maybe our own developers or maybe back to the client, is to come up with a high-level design in one of two forms, either a flowchart or an outline that kind of defines the big steps. What are the big things that are going to need to happen? And that helps you confirm that, yep, I'm on the right track. I have the big picture correct. So let's take a look at that. Here, the application starts, and as the book mentions, kind of a circular or rounded edged picture will represent the starting and ending point of our flow. The squares or rectangles, those will designate something happening, so a process. So think of that as a chunk of code. And then any diamonds are decision points. So you can kind of think of those as later on being translated into an if-else statement, okay? Or maybe a loop, something like that. So let's take a look. In this scenario where we want to be able to enter dog information and figure out how much dog food we need, here's how that application might work. So we set up the kennel. We need a place to put all of our dogs, okay, in the physical world and in our program. So we need a place to have that list of dogs. So we set that up. We create that placeholder. The next thing is to get dog information. So we need some information to be entered into the system. So we can ask the user, hey, give me some information about the dogs that you want, or a dog. So we gather that information, and then we would create that dog. So you can think of a dog object in Java, but again, this could be any language. And then we store that dog object, and that probably gets stored maybe into the kennel or something like that. Those details we don't have to worry about quite yet, and we certainly don't have to worry about exactly what dog info means. Then we're going to have to ask the user if they want to enter another dog. So we need a process to enter one or more dogs. So if the user says, yep, I want to enter more, we'll go back, ask for more information about a dog, create the dog object, store the dog object, and then again, prompt, do you want to enter another dog? So at the point where the user decides I'm done, then we kind of fall out of that loop and we come down here to where the reports are displayed. So displaying each of the dogs, how much food each dog needs, and then at the end, a summary. Here's the grand total of how much food you need to make sure you have on hand for the week. Okay? And then we end up at the end. That's the end of the program. Now there's another way that we can create this same type of thing, and that's just in a text outline. And so here's a second example of what a high-level design might look like. And again, this is just a very high level explanation of how the application is going to work, what it's going to do. No code, no programming details, just a description that anybody could understand. And it's kind of a way to just communicate that, yep, I understand what I'm supposed to be building here, and maybe communicate that back to the client or to me as your instructor, as you're designing an application. This type of information will help me see that, yes, you are on the right track. You know what the big pieces are. So here, same thing, kennel application starts. We're going to create a list or some sort of way to hold all of the list of dogs. Then we start dog entry. So the user is going to be prompted for information about a dog. The dog information is entered. We create that dog object and then store it. When the application is done, the last thing that happens, the dog information is output to the terminal. So information about each dog, and then that total. How much food do we need? Okay, so that's the beginning. That's the very first step, is to understand the problem and then think about how you might break that down. Now, the two examples I've given you will be a great template for you to use as you are working through the labs and the project. So it's time now to practice with Lab 1. And in Lab 1, you're given 3 different applications here. So application 1, 2, and 3. And the goal is already defined for you. Application number 1, calculate the sum, difference, multiplication product, and division product of 2 numbers entered by a user. Keep asking for more input and showing output until the user enters 0. So just like we did with the dog application, we should now sit down and draw out a flow or type out an outline of the steps. So things would be very similar to what we just looked at. So our calculator application starts. We're going to create some place to hold the numbers that the user enters. And then we're going to prompt the user asking them to enter numbers. So enter one number, enter a second number. And then we'd have some looping in there, asking for more input and output from the user until they enter a 0. And a 0 would indicate when we're done. Okay. Output the calculations. So after they enter 2 numbers, display the sum, difference, multiplication product, and division product. Okay. So your job is to create the flow for that. Again, you can either create a nice flow chart if you like doing it that way. That's perfectly fine. Pictures are great. When you send it to me, just make sure that your submission has not the proprietary version of whatever that flowcharting software is, but instead export that as just a JPEG or a PNG or something like that so that I can view it without having the same software that you do. Second application, a guessing game. So a user is going to enter a number. So your game will create a random number, and then your user will guess a number between 1 and 100, and then the program will let the user know if their guess is too big or too small. So we don't have to worry about, at this point, all the details of how we're going to do that. You might already be thinking about, I need a variable for this, and these are the different methods I'm going to need. Try to step back from that by quite a bit and just get a very simple flow down of what has to happen. Same thing with the third one. Application will give a quote based on a color. So let's say the user enters red, then we would get back, when in doubt, make a red painting by K Walking Stick. So we'd get some type of quote back, okay? So what I'd like you to do for the first lab then is create high-level design, either flowchart or just an outline of the steps at a very, very high level. Use the kennel application as an example. There are also examples in your textbook that you can use. Again, keep it really high level, nothing about variables, nothing about which classes you're going to have yet at this point. All right, that's lab 1. I will be back to talk about class identification next. We'll see you there.